So moving on to section 7.5, the objective of this section is to prove various quadrilaterals are parallelograms. And so what we'll do is we'll give you some different theorems to prove quadrilaterals are parallelograms, and then we'll let you try it on some various proofs. Okay? So there's 5 different ways that we're going to allow you to prove that a quadrilateral is a parallelogram. The first one is if 2 pairs of opposite sides are parallel. So 2 pairs opposite sides parallel, then you have a parallelogram. The next one is if 2 pairs of opposite sides are congruent. So 2 pairs opposite sides congruent, then you have a parallelogram. The third one is if 2 pairs of opposite angles are congruent. So 2 pairs opposite angles are congruent, then you have a parallelogram. And the fourth one is if the diagonals bisect each other, then you have a parallelogram. And the last one is if 1 pair of opposite sides are parallel and congruent. So 1 pair opposite sides parallel and congruent, then you have a parallelogram. Okay, so those are the 5 ways we're going to allow you to prove that something is a parallelogram, and we'll be doing proofs in this section. I know it's a lot of things to memorize here, but if you think about it, this method, this method, this method, and this method, the first 4 are all just properties of a parallelogram, but we're going in reverse, right? Because earlier we did if parallelogram, then you had all these different properties, right? 2 pairs of opposite sides parallel, you had 2 pairs opposite sides congruent, diagonals bisect each other, etc. That's the first 4 here are just the converses of what we had learned earlier in the chapter. And then really, number 5 is the only new one that you have to know, which is that 1 pair of opposite sides are parallel and congruent. It's got to be the same set of sides that are both parallel and congruent. And if you have that, then you have a parallelogram. Okay, so let's go ahead and try some proofs with this. Okay, here's the first proof. It's given that this angle right here is congruent to this angle right there. Hopefully you can see that that means that these are parallel because of corresponding angles. And then it's given that angle 1 is congruent to angle 2. Those are alternate interior angles. And hopefully you can see that these are parallel because of the alternate interior angles being congruent. And it looks like I have a parallelogram there. 2 pairs of opposite sides parallel. So let's go ahead and write this out. What you would do is step 1. Let's do these things first. Okay, that's given. Step 2. I know that TS is parallel to VR because corresponding angles congruent will give you parallel lines. And then in step 3, that's the givens, which will give you TV being parallel to SR because if alternate interior angles are congruent, then you have parallel lines. And now I can say that RSTV is a parallelogram because 2 pairs opposite sides parallel means you have a parallelogram. Okay. Let's try one more. Okay, so for this one, it's given that the big quadrilateral is a parallelogram. So I got all these properties there. And AFB is congruent to ECD. And I want to prove that this yellow part is a parallelogram. And so I think I could probably say that, well, I know that these are congruent to each other because they're opposite sides of a parallelogram. And I also know that these are congruent because they're opposite angles of a parallelogram, which means that the two triangles are congruent to each other. And now I can do a bunch of different things there because of that. Okay, so let's take it from there, and then let's see all the different options that I have here. So I can start by saying that I have a parallelogram, and so that means that AF is congruent to CD. Opposite sides are congruent. I know that angle A is congruent to angle D. If a parallelogram, then opposite angles are congruent. I got this given right here, which means that the triangles are congruent. So AFB is congruent to triangle DCE by angle, side, angle. So it's from steps 2, 3, and 4. Okay, so from here, I can kind of pick which way I want to do this. So I can go something like this. I can say that this is congruent to this, and I can say that this is congruent to this, and I already know that this is congruent to this, so by subtraction I know that this is congruent to this, and I can do opposite sides are congruent. So let's do that first, and then I'll show you that there's multiple ways you can approach this. So I can do FB is congruent to EC by CPCTC. And I know that AB is congruent to ED, also by CPCTC, so let's leave that in the same step there. And I can add, I already had in step 2 here, AF congruent, I can add FD congruent to AC, because it's the exact same reason, right? Opposite sides of a parallelogram are congruent. So now by subtraction, I can say that BC is congruent to FE. Okay, and because I subtracted AB from AC and got BC, and now I can do, because I have these two, I can do FBCE is a parallelogram because two pairs of opposite sides congruent means I have a parallelogram. Okay, so that's one way I could have done that. I'm going to just quickly show you another way, because you can, and that's the tough thing about this. When I'm grading these, there's so many ways to get to a parallelogram, but you could have done something like this. I could have said, hey, this is congruent to this, CPCTC, which means, of course, this is congruent to this, by either subs of congruent angles are congruent or subtraction property. And then I could have said, let's choose a different color here, that I know that this whole angle is congruent to this whole angle because of opposite angles of a parallelogram are congruent, and then done a subtraction property to get these two congruent to each other. And from there I could have said two pairs of opposite angles are congruent, which gives you a parallelogram. So there's another way I could have done that. Okay, I'll let you go ahead and now go ahead and try some problems on your own. Okay, good luck.